from what I did last week, okay? So a matrix is a rectangular arrangement of numbers, symbols, or expressions organized. We're not writing this now, because it will take too long to write it down, right? So you will just probably leave about, if you can print it out, that'll be better. If you all can print it out, it might be best instead of writing everything out, right? So leave a few pages and we just run into the definition up here, right? So an example of a matrix would be this, right? It's just numbers spaced out in a rectangular form, okay? This is in a square form here because we call this a square matrix. But it can have rows. Rows will be running from left to right or horizontal, right? This here would be called a 2x2 matrix because it has 2 rows and 2 columns, right? Yeah, bro?
I don't know if it's just me, but me, I see on the screen.
All right, hold on. Nice people in. Hold on. Right, you all see that?
Yes, I've seen it.
All right. Right. So rows are running horizontally. So 3 and 5 will make up your row. Well, your first row. And 1 and 7 will make up your second row. Your columns are running vertically. Okay? 3 and 1 will be your first column. 5 and 7 will be your second column, right? Matrices, rows, and columns. Okay? Right. Let's see what we have here next. The size or order of a matrix is written as rows by column. So this matrix above here, this matrix up here will be 2 rows and 2 columns. Once it's like the same number of rows by the same number of columns, it will be called a square matrix, right? Everybody good there? Right. Let's try and go through what we did last week, right? Row matrix has only 1 row. So you see we only have 1 row here, right? 1 row, but you actually have 3 columns. The 3 columns will be the 3 numbers, okay? But 1 row is called a row matrix, right? Column matrix has 1 column. So you see we have 1 column coming down, but you actually have 3 rows. Okay, everybody good there? Right. Square matrix, same number of rows and columns. An example is just like a 2x2 matrix or a 3x3 matrix, meaning 3 rows, 3 columns, right? Identity matrix is a square matrix with ones running diagonally, right? So you see how we have ones running diagonally here? This is a 2x2 square matrix. This is a 3x3 square matrix. Everybody good there? Right. So these are the questions we looked at. We're going to do questions similar to lower down, right? So what else we have in between here that you'll need to know? Hold on. Right. Matrix multiplication. All right. I'll have to show you all that when we do our question, right? Right. So let me go down. Let me start the questions. Online, everybody seeing? I'm going to send one more message here. Nessie, where Keegan?
He was on his way back home, but I don't know if he'll be joining.
All right, no problem. Well, he'll get the recording.
Yeah.
Right. Okay, that's our face-to-face child, Norisawa. Right, so this is June 2021. I only teach via past paper questions, right? I don't do any textbook questions or anything, right? We just do past papers, straight past papers. Right, so this is June 2021. The question is asking us to calculate the product, well, the matrix product. What does product mean? Product means to, anybody knows? Multiply. You all knew that? Yeah. Product means to multiply. Bro, where your book? Oh, on your lap, you have your calculators. Everybody have their scientific calculators. Where yours? You walk it on. I have some here, but I know how they work anyway. You have one? You have one? You'll bring it for next week, right? Right, let's go. Right, so we're going to work out this matrix multiplication here, right? So we're going to follow. Right. So the thing about when you multiply matrices, you are actually multiplying rows by columns, right? Another thing, for a matrix multiplication to be compatible, this here will be a 2 by 2 matrix, the first matrix. You all seen that? Why is it a 2 by 2 matrix? Because it has what? 2 rows and 2 columns, right? Proper thing. Right, so 2 rows, 2 columns, so it's a 2 by 2 matrix. The second matrix is a what kind of matrix? Not 3 by 2. You're calling rows first. Sorry, yeah, you're calling rows first. How much rows does this matrix have? 2 rows and 3 columns, right? So this is a 2 by 2 matrix and a 2 by 3 matrix. Cool? For matrix multiplication to be compatible, the amount of columns in the first matrix must be equal to the amount of rows in the second matrix. Are we clear? Right? So if it's a 2 by 2 matrix multiplied by a 2 by 3 matrix, if these two numbers are not the same, matrix multiplication cannot be performed. Right? So let's roll. So I'm going to write down the matrices down here. We have 5, 4, -3, and -2. Right? Then we have 2, 1, -4, 0, 3, and 6. So y'all stay with me, right? For those who just joined the class and don't have the notes from last week, let's head up matrices, right? Get up matrices, and then you just put the year and you just do the working. Don't write down the question because I'm sending everything in the group, but I still wanted to write the working, right? So this will be 10A part 1. So let's roll. We're going to perform matrix multiplication, row by column. So watch it. We're going to color coordinate this thing, right? So you see this row here is going to be multiplied by this column here. Okay? So we multiply in position. So 5 is going to be multiplied by 2, and then you're going to add it to 4 multiplied by 0, sorry. Everybody good there? So let's write that down. So this is how it's going to look. So I'll put the equal sign here because it's going to be a lot of multiplication, right? Okay, no problem, Aiden. Come in. You can come in now. Right, so the first multiplication, which is going to form the first number, and my answer will be 5 multiplied by 2, which is what? 5 2s are 10. So I'm going to put 10, and I'm going to put 5 by 2, right? Because everybody knows that's 10, right? Then plus 4 multiplied by 0 is what? 0. Everybody good there? That's your first multiplication. We can put in brackets to know that this needs to be added to get my first number there. Cool? I don't familiarize with these names. This one is Megan. And what's your name again? Emma. Bro, what's your name? Jivan. Jivan, Emma, and Megan. And well, I know you and I know you. Right, there we go. So, next working. Follow with me, right? We take in the same row. This row actually needs to be, the first row here needs to be multiplied by every single column here, right? So you multiply by this column and by this column. So yellow is going to match up with these yellow columns here, right? So let's go. The second working. So it's going to be 5 multiplied by 1, which will give me plus 4 multiplied by 3 would give me 12. That's my second working, okay? To form my second number in my matrix, right? So we go in row by column. So I can put a little arrow to show you what I'm multiplying, right? I'm multiplying this by this. Well, the whole row by, then we did here, and now we go in here. Everybody clear? Right? So 5 by -4 will give me what? -20. 5 4s are 20. A positive multiplied by a negative will be a negative. Right? Megan, you good there? Right. I just saw your head down now. Yeah. Then we go in. 4 by 6 is what? 24. All right? And I'm going to close the matrix down here. Everybody good with that first set of working? Row by column, row by column, row by column. Okay? Chantel, easy stuff, you know. That's how I know what to do. It's like simple multiplication, simple addition, primary school stuff. My son could add this, right? So we go in. Next one. I'm going to color coordinate this too. All right, let's roll the green, even though this green is real bright. So you see this row now? You are actually going to multiply this row by the same 3 columns, right? So you're multiplying it here, here, and here. Okay? So yellow by yellow, and then green by green. Row by column, row by column, row by column again. But we just multiplying the second row now, right? So let me put a different color here, multiplying this by this row, right? Then we go in here by here, and then we go in here by here, right? So map it out for me. -3 multiplied by 2 would give me -6, right? Then -2 by 0 would be +0, right? Everybody good there? Then -3 by 1 would be negative what? -3. And then -2 multiplied by 3 would give me right. So it will be plus -6, right? So I just put the two signs so you know that we plus and everything, right? Then -3 multiplied by -4 would give me what? 12. If you're not sure to do these things, you could use a calculator, right? In this exam, you can't use a calculator, right? -3 multiplied by -4 would give me positive 12. And then -2 multiplied by 6 would give me -12, right? Everybody good here so far? Right, so let me roll. Sending this down. Right, so we need to work out each one of these workings here to get the final matrix, right? 10 plus 0, 10, 5 plus 12, -20 plus 24. Now, assuming we know how to do these things, right? Because this is like Form 1, to add these things, right? -20 plus 24 is +4, right? Close your matrices, your matrix here. -6 plus 0, -6. -3 plus -6. Now, a positive and a negative will give me a what? A positive by a negative will be a negative, right? So this will be -3 minus 6, which will give me, no, -3 minus 6. Anybody?
-9.
Thank you. -9, thank you. And then 12, a plus and a minus will give me a minus, right? So 12 minus 12 will be 0. It's 12 minus 12, 0, right? Okay? So this here will be my complete matrix multiplication. Point to note, when you calculate a matrix multiplication, it will be the value of this first number here, which is 2, and then the value of the last number. So it will be 2 rows and 3 columns. That's how your matrix will always be multiplied to be, right? So I want you to put your matrices as a heading, right? Obviously, you put your date first. June 2021, number 10A, part 1. Right? As you walk, Statewide, the two matrices in A part 1 are conformable for multiplication. So that's what I was speaking about when I gave you all this underneath here. When I said the amount of columns in the first matrix must be equal to the amount of rows in the second matrix for matrix multiplication to be conformable, right? So let's write that out. So you simply put it as the number of columns in the first matrix must be equal to the number of rows in the second matrix, right? So above we had a 2 by 2 matrix multiplied by a 2 by 3 matrix. So these two numbers will equal, therefore matrix is conformable. much. Now listen to me. Let me give you all what it is first, right? So to find the inverse of a matrix, which is written in the form, so let's say the matrix is A, right? The inverse of a matrix will be A to the negative 1 power. That's how we write the inverse of a matrix, right? Whatever matrix it is, you could just give it a name. That's somebody trying to come in here. Hi, Christian. Right. So A to the negative 1 is the inverse of the matrix if it is A, right? So this will be equal to 1 over the determinant of A, okay, multiplied by the adjoint of A, okay? So I need to tell you what the determinant is and what the adjoint is, right? Okay, so there we go. The determinant. So I explained it thoroughly last day, but I just going through it in its totality today because we have new students, right? So given a matrix, all those who have it written in your book, write it over. I tell you, a little repetition is excellent for this thing called maths. Writing the same thing over and over is how things stick. You seeing there? Seeing good? All right. So given a matrix A, which is equal to, we'll just be given the letters, we're using letters as numbers, right? So we'll call it A, B, C, and D, right? So the determinant of a matrix, determinant of a matrix written as A, whatever the matrix is, with 2 bars on each side. Chiffon, what kind of horse is this, brother man?
So I'm not in the country right now.
Oh, you're not in the country, all right. Yeah, I really see your posters in the airport, all right. But you get through, at least inside. Thanks for making the effort.
Yes, sir.
Right. So the determinant of a matrix written as A with 2 bars. Once you say A with 2 bars, it is the determinant of the matrix. So listen how we find this number, right? So the determinant of A is actually equal to the A multiplied by the D, which is the common A multiplied by common D. So I'm going to put that here. A, I'll put the multiplication sign. Multiplied by D minus B multiplied by C. The A multiplied by the D minus the B multiplied by the C. It's like the 2 diagonals we multiplying, right, Jivan? Okay, Megan, we good there? I seen you writing plenty, but you're listening, right? Yeah. Right, so I'll give all the time to write, like if you want to listen and then write, I will give you time to write. But if you can do it, if you can multitask, no problem, right? So this here is the determinant of my matrix. When you work out that, you will get 1 number, right? So let's go. The adjoint. What is the adjoint of the matrix, right? So the adjoint of A would be, you are actually interchanging D with A, and then you multiply B by -1. So if it's negative, it becomes positive. If it's positive, it becomes negative, right? And then this C is going to be multiplied by -1, right? Now I can guarantee you all that these things not going to stick in all your head today, right? But you know when it will stick? With constant practice. Okay? Those who weren't here last week, go and write out my notes from the last class. You all only get the notes today. So next, probably right tomorrow, you'll write it out, right? Because there are plenty notes up here. Plenty notes going up, right? Right, so we move in. So we have the adjoint of A, we have the determinant of A, right? What is the inverse? The inverse of A, whatever the matrix is equal to 1 over the determinant multiplied by the adjoint. So let's work. I'm going to write down. So we're gonna let our A be the matrix that they give us, right? So we're gonna write with, right? So let A be equal to 5, 4, -3, -2, right? Okay. So we have 5, 4, 5, 4, -3, and -2. Everybody good here? This is the matrix. We're saying let A be equal to that. All right? Cool? Jivan, you with me? You sure? Right, so there we go. We want to find the inverse of A, but to find the inverse of A, I must first find the determinant of A. What did I just tell you all the determinant of A is? It's right here. Okay? So I find this is looking like, I want to write this better. I was watching the screen and I was writing and I find that it's written Ben. The multiplications. So I'm going to put that properly. So multiply, right? So what is your A in this matrix? Who could tell me? Anybody? What is A, common A in this matrix? Common A is which letter here? Negative what? That's the adjoint. Look what it is up here. A, B, C, D, right? This is the adjoint. The adjoint is like we flipping up some of the matrices, right? Well, some of the numbers. So A, capital A is equal to common A, B, C, and D. Cool? So what is A, common A in this matrix here? 5. What is B? C and D. Right, so let's work, right? A is going to be 5. So I'm going to put 5 multiplied by what is D? D is negative 2. Cool? That's your first multiplication. Minus what is B? 4 multiplied by what is C? Right? Everybody good there? We're working now. Right? So this will now be equal to what by? This will be 5 multiplied by negative 2 would be negative 10. Excellent. Minus 4 multiplied by negative 3. So I just leaving this. I'm leaving this on the bracket. Very good. Oh, you don't need to put it in. Wait. All right. So there'll be 10 minus. So I'll just put negative 12 here, right? Negative 12. So you all see two minuses. A minus and a minus is a boom. Right? So it's actually negative 10 plus 12. Negative 10 plus 12 is what? Anybody? Negative 10 plus 12.
2.
Positive 2. Right? Everybody good there? So the determinant of my matrix A is 2. Easy pickings or it's hard? Anybody struggling here? Hey, I need to see that syllabus, sister. They can't get from school. You're all in contact with your teachers. You all have like a WhatsApp group or everything. So, because I study, I teaching you here and I study, like, if you're not doing this, it might make sense you learning this or not. So I could probably just let you know when we're doing topics that are on your syllabus. Right, so there we go. We have this. Now we roll into the adjoint. We need to find the adjoint of A so that we can multiply 1 over the determinant by whatever the adjoint is, right? So we go in. Adjoint of A, right? So the adjoint of A would be equal to 1, not 1, sorry. I was going to write the whole inverse there. Right. So remember I told you we interchanging, right? So D takes the place of A takes the place of D, then you're multiplying B by negative 1, you're multiplying C by negative 1, right? So let's perform that mix-up, if you want to call it that, right? So look, my A is above there. So the adjoint of A, what comes in the place of A up here? 5 is where A is, but what we put in there now? Boom, negative 2. Shatter like a come off for them, girl. And then 5 goes where? Here, right? Where negative 2 was. Everybody go to that first flip? And then I'm multiplying 4 by negative 1. 4 by negative 1 will give me negative 4. And then negative 3 multiplied by negative 1. Negative by negative is a. So it would become. Mr. Rishi, I find you standing slack off, eh? Are you reaching class?
So, my laptop updating for the past 2 hours now.
All right, we go buy that. We buying that gym today, right?
I know I've reached class late, you know that.
All right, bro. Right, so negative 3 multiplied by negative 1 give me what? 3, positive 3. And negative by negative is a positive, and then 3 multiplied by 1 would give me 3, right? So it's like whatever is here, and here is like you're applying negative to it, right? So if it's positive 4, it becomes negative 4. If it's negative 3, it will become positive 3. That's what we did down here. We clear? So this is the adjoint of A. So watch how much times I write these formulas, because I want you all to understand that repetition is everything. Writing these things over and over is how it will stick in your brain, right? So I'm writing over what the inverse of the matrix is. It's 1 over the determinant multiplied by the adjoint of E, right? So we go in. What did we find our determinant to be? 2. Excellent. Multiplied by what is my adjoint? It's that matrix there, which is -2, -4, 3, and 5. Right? Now, you can't leave it like this unless they ask you to probably simplify it, but you can't leave it like this. The only thing I'll ask you to do is like you could just drop that multiplication. So let's put a half by -2, -4, 3, and 5. So this here will be the inverse of A. Right? You think you'll do one in this if I give you one? Huh? Where are we not unclear? I don't know.
Yeah, excuse.
Which one is day one? Yeah, we're going right back up. Day one. Right. So you take the 1/2. This is called scalar multiplication, right? You take the half and you multiply by every single number within the determinant. Not the determinant, the matrix. But if you leave it like this, you would get full marks. If they put to simplify it above here, right? If they tell you to write the inverse of this matrix in its simplest form, we'll need to multiply it out, right? So I just want to work it out for Karishma to see what she saw online, right? So -2 multiplied by a half would be what? -2 by a half is -1, right? -4 multiplied by a half, -2. 3 multiplied by a half, 3 over 2. And then 5 multiplied by a half would be 5 over 2. Everybody good there? We good, right? So this here would be the inverse of E, right? You could write it like this, as I said, or you could write it like this. Right. So January 2018, we have it's question 11, part C. The matrices A and B are given as A is equal to -1, 0, 3, and 2. B is equal to -3, 2, 1, 1, 4, 6, right? So you all weren't here when we were doing the order of the matrix. So the order of the matrix is basically if it's 2 by 2, 3 by 2, whatever, right? So who can tell me what is the order of this first matrix? How much rows, how much columns? 2 by 2. Everybody good there? 2 rows, boom, bang. 2 columns, boom, bang, right? For B, how many rows? 3. 3 rows, 1, 2, 3. How many columns? 2. So this is our 3 by 2 matrix. Straight off the back, this compatible for multiplication if you do it in this order. If you do A multiplied by B, no, right? So they're picking up because these two numbers are not equal, right? So they didn't ask us that yet. The first thing they asked us is to find the determinant of A. So this is where I want you all to piggyback off what we just did, right? I've given all you 3 minutes to try this here, right? Piggyback off what we just did. Let's turn the page, you'll see the whole process, right? Online, turn the page, watch the process, get it done. So I'm just writing what A is here for you all. -1, 0, 3, 2. So I'm giving you all a chance to try. Write your formulas, right? I will start off the formula for you all. A -1. What is the Chantal? 1 over what? The formula. You have to check in your book. You ain't going to see it, your sister. The determinant of A multiplied by the adjoint. That's when ADJ, adjoint of E. Right? So come on, let me go. Everybody should be able to handle this. Once you look at the question that we just did, you will be able to handle it, right? Hey, I can pause here, right? That's it, right? Composure is everything, right, Chantal? We know we have a formula for the determinant of A, right? What is that formula? Anybody? What is the formula for the determinant of A? A by D. I don't put the multiplication sign again, right? Because the multiplication sign is understood, right? So A by D minus B by C. Everybody good there? So Chantal, composure, right? You know this is common A, you know this is common B, you know this is common C, you know this is common D. You have those values, right? So let me go. It's just a matter of plugging them in now. So A is -1, D is what? What D is? Look at the matrix. No, D. What value is D? No, it's not -2. It's +2. Yeah, it has nothing in front of it, right? So this is 2. Minus, what is B? B is, when I put brackets, guys, brackets mean multiplication, right? So you can put them in brackets like this. And then C is what? 3. See how easy? So let's go -1 multiplied by 2 minus 0 by 3. What the answer be? Give me the straight answer. You can work it on a calculator. -2. Somebody second that -2. You get that? Anybody get that? You all got that? You got that? Emma, you got that? Where went wrong?
I think the -1 and 2.
Okay. Right. So if you want, you can put these little, you can put the common A above here, the B, the C, so you know what you're working with, right? Caleb, you get us? I know you finished fast. You get us? But you see where I went wrong? Dejan, you get? You understand what's going on here? I need to ask questions online. If all you need to get that further explanation, let's talk, please. Right? Everybody understand it now? That's the determinant. The adjoint is a little easier. So let's put in the ADJ means adjoint of A, right? So give me the adjoint. Anybody? 2, well, it's nothing like -0, eh? 0 is 0, right? Right? This 3 will become what? -3, and the -1 will come underneath here, right? Did you all at least get the adjoint? Yeah. Everybody have the adjoint? Right. So we're going to proceed to find our inverse now. So there we go. Send this down. No, not you. Right. So the inverse of A, which is A -1, will be equal to 1 over the determinant. What is the determinant of A? -2. Everybody with me there? Huh? Yeah. Multiplied by the adjoint. I'm not going to put the multiplication sign because it is understood, right? What is the adjoint of A? Call it out for me. 2, when I ask you to call out these things, is to make sure they're following and I'll know where I'm watching, right? So you all see what the adjoint of A is there? Right, call it out. 2, 0, and negative, right? That's the adjoint of A. We're leaving it just so, right? We ain't going to try to complicate things because I've seen how they use it in part 2, right? So write if you need to write. Fix where you need to fix. So the identity matrix, I read it as a note before we came to this. Your identity matrix would be 1, 0, 0, 1 because it's 2 by 2 matrix you got to deal with, right? So the identity matrix would be a 2 by 2 matrix where 1 is a diagonal and your zeros form the other spots, right? This is your identity matrix. It's a 2 by 2 identity matrix. So when we multiply the inverse of A by the original matrix A, we're supposed to get this. This is what we're supposed to get, right? Are you ready to work? Let's work. I'm going to write it out, right? So A -1, which is the inverse of A, multiply. Now you realize you didn't put any sign in between here, right? But we're supposed to know that multiplication is understood. Everybody clear there? All right. So don't get frightened because they didn't put any sign in the middle there, right? So let's go. I'm going to write down what the inverse is. So the inverse is -1 over 2 multiplied by 2, 0, -3, and -1, right? What's the original matrix? Who can tell me what your original matrix was? Check it in your book. What was the original A? -1, 0, positive 3, and positive 2. Everybody good there? Now, this is why I do like to multiply the determinant into the matrix, because having fractions here, that's cumbersome everything. Let me leave that half outside, that negative half, and at the end, we will deal with it, right? So let me go. So I'm putting back the negative half, right? And I'm going to do my matrix multiplication. Boys, you all weren't here when we do that, when we did that also, right? So let's go. So it's going to be row by column, row, same row by column. Everybody good there? Then I'm going to use a different color. It's going to be row by the same column. I'll just put the blue next to it, right? And then row by the same column, right? So let's work.
So negative 1 or negative 2?
What for down here?
What
are we talking about?
I see you put equal and negative 1 over 2.
Right, so I put back the negative half, right? Which is in front of the brackets.
Right.
Remember, this was the inverse I wrote here. Look the inverse above here. A to the negative half, or the inverse of A is equal to, well, the negative was underneath, but they could establish it as negative half. Because this is like positive 1 here, negative half, so a positive divided by negative is a negative.
Same.
That's where I get the negative half from, right?
Right, sir.
Yeah. Right, so we work in. 2 multiplied by negative 1 will give me negative 2 plus 0 by 3 would be. Everybody good there? Who doesn't understand how I got that? Megan, you good? We go now again. Row by column, yellow by yellow, right? 2 by 0 would give me. And then 0 by 2 would give me 0. You're adding each multiplication that you make, right? Dehan, you here? You sure? Watch it there. Blue by this second row now by second column. Second row by first column. Second row by second column will give me the 2 workings for here, right? So let's go. Negative 3 by negative 1 will give me positive 3, and then you have plus negative 1 by 3 would give me negative 3. You with me there, Dehan? Then negative 3 by 0 would give me 0 plus negative 1 by 2 would give me. So come on, ask me questions. I doubt everybody catch that. Online. Kanis, you good here?
Yes, sir.
Everybody good here? So let me work it out. Javan. Good to go? Where you lost? Tell me where you lost. All right, that's fine. Let me take it one at a time. And what was your question? Where this negative 3? This one? Remember, we get this from here. Right? This is the inverse. I put this exact same thing here first because it's the inverse of A by A, right? So I put this exact same thing here. And then I multiplied by E, which is the original matrix. That was the negative 3 you're talking about? Right? Anybody have any other question? Right, what's your question? Negative 3 by negative 1 and negative by negative will give you a positive, and then 3 by 1 is 3. So you could put the positive in front here, but you don't need to put it. All right? And then negative 1 by positive 3 would give you negative 3. Cool? Any other question? I'll run it back in. All right, so we just working out. I think what's on right here now. Yeah, so negative 2 plus 0 gave me the negative 2. 0 plus 0 is 0. 3 minus 3 gave me 0. And then 0 minus 2 will give me negative 2. Cool? Everybody good there? Now, the number outside the bracket needs to be multiplied by everything within the bracket. Right? Right, Megan? Right. So we go in. negative a half, let me put the multiplication. So there'll be negative a half multiplied by oh no, she was getting problems with internet. Miss Chala now coming.
So you want a multiplication, right?
Right. No, but you have to do it here because we need to get the identity matrix. So we have to complete it, right? So negative a half by negative 2, then negative a half by 0, then negative a half by 0, then negative a half by the last number, which will be negative 2. Everybody with me so far? We have to show that it's equal to the identity matrix, right? You with me here, Caleb? Right, so there we go. Negative a half multiplied by negative 2 would give me what? You can work these things, eh? 1, positive 1, right? Positive 1. Then anything multiplied by 0 is proper thing, right? Anything, the second one here, anything multiplied by 0 is negative a half multiplied by negative 2 would give me 1. Right, Chantal? We could. Yeah, you'll lose marks because we need to show this. This is the identity, not this up here is not the identity. This is not the identity. Right? So, and we get the identity matrix, it's just 1, 0, 0, 1. And you can write the word shown, or you can just put a little box. This box means that you showed it. Right? But you must complete the proof with either shown or you put the box or whatever you want to write. Okay? So I know some of you. Right, so a squared is actually a multiplied by a. Everybody good there? A multiplied by a. So we're going to perform matrix multiplication of a multiplied by a. So what was a? So you're multiple multiplication sign. It's just like a by a, right? Who could remind me what a was? So I will now scroll up. Negative 1, 0. Somebody second this. This is what A was? Right. So it will be that multiplied by itself. Negative 1, 0, 3, and 2. Cool? You gotta perform matrix multiplication here. Come on, you all try it. Matrix multiplication is probably the toughest thing in matrices. So try it. I want you all to try it. Row by column. So you're going to have a big multiplication here. I'm going to color coordinate for you. So row by column. Row, the same row by... Go ahead, bro.
Yeah, you're sending this after video.
Of course. Yeah, of course.
All right.
Right? Then you go in row by same first column and then row by second column. Right? So there we go. I give another 2 minutes. All right, let go. Composure is everything, right? Okay? So let me hear what we do, right? Because I feel all in seen it, right? We reason all this. Watch it. Let's go down and hit the numbers we're going to multiply first, right? So negative 1 by negative 1. Cool? There we go. Negative 1 multiplied by negative 1 will give me positive 1. Right? Plus 0 by 3. 0 by 3 is 0. Plus 3. Right? Everybody good there? That is the first multiplication there. Right? Second multiplication. I reason this now. And then we go down and hit it, right? I'll put back that 0. 0. Right. So there we go. I hit it, right? So we go in negative 1 multiplied by 0. Okay, what I'll be? 0. And then 0 by 2 would be 0. So this will be plus 0. Everybody good there? Day 1. We go now again. I want you to do the same thing with the second row for me. Come on, try it. Do the same thing with the second row. Right? So you're multiplying 3 by negative 1, then 2 by 3. Then 3 by 0, and then 2 by 2. Do that for me. Yeah, as I'm giving. Right. So now we have 3 by 0 would be 0, and then 2 multiplied by 2 would be 4. Everybody good here? Right. So 1 plus 0 is 0 plus 0 is negative 3 plus 6 is, and then 0 plus 4 is 4. So this here is what a squared is, right? Or a multiplied by e, right? Anybody got it? Anybody actually got it? Anybody? You there?
I didn't get 2 plus 6 at all.
2 plus 6. Now, but that's just a simple mistake. This video got some missing, but let me run it back through, right? So for part A, they said to explain why the matrix product A is not possible, right? A is equal to this 2 by 2 matrix, B is equal to this 3 by 3 matrix. So because the number of columns in A is not equal to the number of rows in B, matrix multiplication is not possible, right? Now, for part B, without calculating, state the order of the matrix product BA. So I'm going to put the product of B first. What is the product of B? Actually, not the product, sorry, the order. I say product. What is the order of the matrix B? 3 by 2. Excellent. Pay attention. It's a 3 by 2 matrix. That's the order. Right, Chantel? That's the order. And then what's the order of A? 2 by 2. Proper thing, right? Now, how can I state the order of what the product would be or the answer would be without doing any multiplication? I told you all in the question before. How would I determine the order? I think it was the first question we did today. I just show you all at the end, but I didn't really give a note on it. Who can remember? Nobody remembers? It is the number of rows in the first matrix and the number of columns in the second matrix, right? So the answer straight off the back will be a 3 by 2 matrix. We don't need to work it out to know the order it would be, right? So let me give you all a note to that effect. What's this here? What is this? So let's put this note for me, right? So note, right on my note, Caleb, the order of the product of 2 matrices is the number of rows in the first. Now we listening to me right now. In the first matrix, followed by the columns. Should I squeeze that in there, boy? I'm coming down here, guys. By the columns of the second. Matrix. Good. I don't know, Sir Jivan. Right there now. Everybody good there? Yeah, you're right. I'll pause. I'll have to do this one for you because you all won't be able to do this, right? So 10A part 1A, right? Find the matrix product of this, right? So let's go. This is a 2 by 2 matrix. And what is this here? This small one here. This is our what? You could tell me. 2 by 1. Excellent, right? So matrix multiplication is compatible, right? Because you see the number of columns in the first matrix is equal to the number of rows in the second. Everybody good there? So matrix multiplication is compatible. So let's work, right? Move this around. Move this around. Right. So I want to write it over a little bigger. So we have -1, 3, 4, and h multiplied by k and 5. Everybody good there? So let me go row by column. So look how it's going to go, right? So there's only one column in the second matrix, right? So it's going to be row by this column, and then this row, the second row, by the only column it has there. Everybody good there? Now, -1 by k would be what? -1k or just -k, right? You don't need to put the 1 in front of the k, okay? You're multiplying it. Then 5 threes are
15.
So this will be plus 15, okay? Then this multiplication we're going to do not coming on the side here, because once you go to that second row to multiply by the column, it means you're going in the second row here, okay? So 4 by k will give me 4k. Then h by 5 will give me 5h, right? Could we add or subtract anything here? Could I do k plus 15? Day one. Could I add or subtract unlike terms? These are unlike terms. This is 4k and this is 5h. Can we add these things? No. No, we cannot, right? So that's the answer there. You can't do anything else there, right? So let me see what it wants us to do next. Right. So they came and said, hence. Once you see hence, you're using the answer from the part you just did, right? Hence, find the value of h and k that satisfy the matrix equation, which is what they just give us here, this, right, is equal to 0. Okay? But we just calculate what this is. What this is here, Megan? What we calculate that to be, that matrix multiplication. What did we calculate this to be? This part of it. -k plus 15, excellent. And what is underneath? Nice, right? So we have 4k plus 5h, right? And they are saying, I'm going to put this in the brackets, they're saying this is equal to 0, 0. So who could take an educated guess what's lining up here, boy? What will be equal to what? What's the first thing that will be equal to what? Who could watch it and tell me what's going on here? Anybody? Online too? Huh? Let me deal with the first column, the first row first, huh? What is equal to what? Who could watch it and tell me, take a guess, because I didn't do any like this. What are you thinking about?
4 multiplied by 15 plus 5h is equal to 0.
4 multiplied by 15 plus 5h is equal to 0, no? So here what? And we didn't do anything like this yet, right? So here what's going on here. The positions lining up. So you see that -k plus 15, that will be equal to 0. Or whatever the top number is, right? So I can say, therefore, -k plus 15 is equal to 0. That's the first equation I could form there. This equation I can use to find the value of k. You all seen that? Right? So this k is negative, so I'll carry this k on this side so to become positive, right? So I'll leave 15 here and I will have 0 minus k will become plus k, right? So 15 will be equal to 0 plus anything will be whatever it is, right? Which is k. So 0 plus k would be k. So I found the k. K is equal to 15, right? So this is the first equation I could have formed from this equality here. The top row is equal to the top number here. So let's say I had 3 instead of 0 here. It would have been -k plus 15 is equal to 3 if I had 3 instead of 0. We here. Right? Everybody good there? So we found k, right? What is the second equation I could form here? Just piggybacking off what I just said there. What's the second equation I could form here? Anybody could tell me? If this row is equal to 0, what goes on with the second row? 4k plus 5h would be equal to 0. because there's a 0 in that second row there for the answer. So this is equal to 0. This is equal to 0. Right, Pollard? Right. So, and I just found, so when K is equal to 15. Now I have 15 is equal to K, but it's the same as writing K is equal to 15, right, Caleb? Okay. So when K is equal to 15, what can I replace this K here with? 15, right? So it'll be 4 by 15 plus 5h is equal to 0. Y'all stay with me, eh? Watch it now. 4 by 15 is what? 60, right? So 60 plus 5h is equal to 0. Now if I want to find h, what I need to move here? What I need to move the 60, excellent. When I move 60 here, what do I do with it? Minus.
So negative
Excellent, guys. 5h is equal to 0 minus 60, right? 0 minus 60 is what? Positive 60 or negative 60? 5h is equal to negative 60. Okay? What we do next? We want to find h. What we have to move next? The 5. Excellent. So you carry 5 here and you divide it, right? So h will be equal to negative 60 divided by 5. H will be equal to what?
12.
Positive 12 or negative 12?
I just get positive 12.
Negative 12, right? Because this is positive and negative divided by positive is a negative. Negative 12. Caleb, what you seeing down there, boy? Bro, you're lucky, nah? You're lucky. Anytime you drift, you're missing something. Trust me. So I want to go up for you. Anybody see it? Right. So from this here, right, we had k is equal to 15. Cool? So I replace this k here with the 15. That is 4 multiplied by k, so it will be 4 multiplied by 15, which gave me 60. Okay? This 60, there's no sign in front of it, but plus is understood. Right? So this is like plus 60. When you move it to the right, you do the opposite of plus, which is to minus. Cool, Megan? Right. So 0 minus 60 would be negative 60. Right? I take the 5 here because what is understood between this 5 and this k, Chantal? What operation is understood here? There's no operation. So what is understood? Multiply. The opposite of multiply is to right. So that's why when I carry the 5 to the right, I divided it. Right? So h is equal to negative 60 divided by 5, positive 5, and I would get negative 12. Right? Watch over the video when you go home, right? So there we go. Right, this is where the toss go and get real. So they want us to use the matrix method to calculate a simultaneous equation. But you hear what I said? The matrix method to calculate a simultaneous equation, right? So there we go. If you look at the simultaneous equation, you can kind of see that it is a matrix, right? You see like the 2, the 3, the negative 5, and what is understood in front of that y? Who could tell me what number is understood to be here? 1. Perfect. Right? Everybody knew that? Caleb, you knew that? What's in here? Caleb, right? So may I be excused? Yeah, Christian, go ahead. So it's like as you watch it, you'll see the matrix. So the matrix will be 2, the 3, the negative 5, and the 1. You all see that? And then the 2 variables here would be the x and the y. That forms a column matrix. From above, at the beginning of the class, I told you all that column matrix is a matrix with 1 column, right? Then this will be equal to, what are the 2 numbers on that side now? 5 and 13. So from this, watching the simultaneous equation, you can actually see the matrix, right? Right, day 1? Okay, so this is the matrix here. Now they want us to use the matrix method to solve the simultaneous equation. So what we actually need to do in theory is you need to take this matrix and carry it on this side, right? When you carry a matrix over the equal sign, you need to find the inverse of that matrix, right? So I'm going to say, let A equal to 2, 3, negative 5, and 1. So I want you all now I'm going to give you all that 3 minutes to find the inverse of A. You're going to scroll up and see how I did the last one and try. I'm giving you all. Right. So I will stay composed. Right. I would look back. I would first see what my formula for the inverse of a matrix is. What was the formula? 1 over what? No, not the adjoint.
Determinant.
The A with the 2 bars is the determinant. You all at least had this? Multiplied by the adjoint of A. Everybody good there? That's the formula. That's the first thing everybody should have that written. You know what else you should have written? With your composure, you can go back and see that the determinant of A is equal to A multiplied by D, not D. A multiplied by D, right? Composure. Okay. Right? Minus B multiplied by C. Composure is everything, right? You know what else you'll see when you turn back, Mr. Dejuan? You'll see that the adjoint of A is equal to, right? Is equal to DA and then negative B and negative C. Cool? When you turn back, you're supposed to see all this. And all this is for a matrix A, which is equal to A, B, C, D. We good here, people? Right? So this is for if you have a matrix like this. Okay? We roll in. I need you all to write this. We have it written. You have it written, you all have it written, right? Right. So watch it. Let me take our pencil or our pen, right? And write a little A above here, a little B here, a little C here, and a little D here for guidance, right? Right, Jevan? We do this for guidance. Right. So, right. So let's find the determinant. So what is A? Give me A. The determinant of A. What is common A? 2 multiplied by what is common D. 1 minus what is common B. Multiplied by what is common C. Negative 5. I put these in brackets. Let's just show we need to multiply these two separately, right? And when you work it out, let's give me the answer. What is the determinant of A? Wait again, what's the final answer? 17? Somebody second 17.
Yes, I get that.
All right. Caleb, Dejuan, all you get this? Dejuan, you get this? Megan, you got this? Emma, you got it? You see what you're doing wrong? Chantal, you got you?
Yeah.
Right, there we go. No problem, Dean. Right. So let's write down, I'm going to write down the adjoint right next to it, right? So the adjoint of A. Okay, let's write down what the adjoint would be. So A takes the place of D. So what would be? Somebody call it out. Anybody had it written down? I need to scroll up. 1. What comes here? What comes in place of D? D. 2. Right? All right. What come in here? Negative 3. And what come in here? Negative 5 or positive 5? Something looking wrong. Here will be positive 5. B is negative 3 and C would be positive 5. Right. This is the adjoint. Anybody make it so far? Huh? We are the adjoint of A. We have the determinant, we have the adjoint. Everybody good here? Right. Scroll back. Look, I go and write this formula again because I wanted to stick it on the header. What is the inverse of A, Caleb? 1 over the determinant of A multiplied by what, Megan? The adjoint of A. Right, Chantal, you good there? So, Chantal, it will be 1 over, what is the determinant of A? What number we get? 17, excellent. Multiply by, what is, Emma, what is the adjoint of A? I ain't put no multiplication sign, let's put it next to it, right? Right, what is the adjoint of A, Megan? 1, negative 3, 5, and 2. Everybody good here? Okay, this is the inverse of A. So let's work. 17 gonna be very. Right, that's all they asked for? No, right. So we have that. So what we going back up to, we need to solve the simultaneous equation. That's only the first part of the work, and we now started. So this here is the original matrix that represents my simultaneous equation. Okay, so what are we going to do now? We're moving this, we're bringing it here, and we need to place the inverse right in front here. Right? Everybody cool there? So what you're going to do, I'll leave an xy on the right. Follow it, Caleb? I'll leave in the xy. So I put in therefore, dot, dot, dot means therefore, xy is equal to, then I'm going to place the inverse here. 1, negative 3, 5, and 2. And what was it? 2 numbers? 5 and 13. Everybody with me thus far? So here I want you all to do now. Again, all the work in this class. I want you all, leave the 1 over 17. We are multiplying this by nobody yet. But I want you all to perform the matrix multiplication for these two matrices here. Is it conformable for matrix multiplication? This is a what by what matrix? What's the order of this matrix here? 2 by 2. And what's the order of the second matrix? 2 rows and how much columns? 1. So is it conformable for matrix multiplication? Right, let's work. Right? Work it out for me. Hey, I could pause here, right? Let me go, eh? Composure is everything, eh? I was fed up telling all of that. Composure is everything. So we're doing row by column. Let me give all that a little highlight there. This row by this column. Cool? Right? I mean 13, eh? I don't mean 1, eh? This is 13, eh? But I want to put our next color here. So I put in this row by the same column, right? But I mean 13, not 1 and 3, eh? Okay, so let me go. So it's going to be 1 by 5 will give me, negative 3 by 13 will give me, negative 39. Close my bracket, because once I take that second row to multiply, you know you're going underneath, right? 5 by 5 is 25, and 2 by 13 would be 26. Cool? So this will be equal to, right, work it out for me. 1 over 17 is still in front, right? 5, a plus and a minus will give me a minus. So you know it's 5 minus 39. What's 5 minus 39, my children? Positive or negative? Negative 34, right? 25 plus 26, 51, right? Now we're going to take the number in front of the brackets or the fraction and multiply it by everything within, right? So it will be 1 over 17 multiplied by negative 34, and also 1 over 17 multiplied by 51. So somebody tell me what the values of x and y would be here, which is what we're trying to work. Make them brackets bigger. Somebody go to their calculator, punch in 1 over 17 multiplied by negative 34 and tell me again, please. Right, so what's the final two answers here? So this is actually X and Y you're working to find here, right?
So negative 2, y is 3.
Excellent. So 1 over 17 multiplied by negative 34 will give me negative 2. And then 1 over 17 multiplied by 51 would give me 3. So I can now say, therefore, X is equal to negative 2 and Y is equal to 3. Because remember, the X is on top, so the number on top would be X. The Y is underneath, so the number underneath will be Y. So we use matrix method to find X and Y in a simultaneous equation. Everybody good there? Perfect. I'll pause this. Chantal. Right. So we're going to deal with transformation matrices now. So you can head up that. Transformation matrices. Right? Right. So we're going to deal with reflection matrices. So, right. So the transformation will be a reflection in the x-axis, right? Okay, and this transformation matrix would be 1, 0, 0, negative 1, right? That's the first transformation matrix, which is a reflection in the x-axis, right? Then we have a reflection in the y-axis. In the y-axis. Right, Jivan? You're right, then? Use our speedy too, buddy. Right. So this will be negative 1, 0, 0, 1. Right? That's a reflection in the y-axis. Then we have a reflection in, now you'll have to learn these things, in the line y is equal to x, right? So that will be 0, 1, 1, 0, right? This is not the identity matrix, guys, because it's always 0, 1, 1, 0. The identity matrix will be 1, 0, 0, 1, right? Then reflection in the line y is equal to negative x. So this matrix would be 0, negative 1, negative 1, 0. Then we have rotation matrices. Rotation matrices, right? So we have a 90-degree anti-clockwise rotation about the origin, right? So no space here, but yeah, man, I have space. About the origin, this will be about the origin, this one will be 0, -1, 1, 0. Right? Then we have a 180-degree rotation about the origin would be -1, 0, 0, -1. And then we have a 270-degree anti-clockwise, which is like a 90-degree clockwise rotation about the origin, and this will be equal to, hold on, this will be 0, 1, -1, and 0. All right. They here. I see your mom just messaged me. You can log into the vehicle if you want to know, if you had it. The link in the group, right? Yeah. Okay, mom. She coming out now, right? All right. Okay, bye. I'll see you next week, right? Oh, the class was good. All right, nice. So I'll see you next week. Take care. All right. This was the last one, right? Enlargement. Oops. Right, so we have our enlargement matrix, right? Matrix. Right, so enlargement matrix is an enlargement by scale factor key, right? So this will be enlargement key from the origin. Put in from the origin. Enlargement key from the origin. This will be K00 K. Whatever the enlargement is, K would be the number that takes this place here, right? Also, I note because I keep throwing around the word origin, right? So note, origin is the coordinate 0, 0, right? That's your origin. Okay? Everybody have everything here? So we might just have time to do one of these, and then by that time we will lock off, right? And you will try the rest. Online, raise your hand if you have all my notes. There's not no plating and all here. Serious business, you know. Right. So we're scrolling down, right? Let me send this down, right? Right. So June 2018. A transformation T is defined by the matrix T is equal to 2, -1, 2, and 0. They told us that the transformation matrix is this, right? So the point A, which is 2, 3, is mapped onto the point A prime, which is AB under transformation T. So you're going to apply a matrix transformation to a coordinate. So the first thing we actually need to do is you need to write a coordinate in vector form, right, Caleb? You need to write a coordinate in vector form. So what is vector form? Right? So let us write on this. Right. So vector form, one ready. Right. So the vector form of a coordinate represents its position as a column vector from the origin. Right? The origin is 0, 0, right? So if I give you a point P, right? So write this in blue. Nah, let me leave it in red. So a point, so this is your first node, this is your second node, right? So a point P, let's say is X, Y in, well, on the X, on none of the XY, on the Cartesian plane, right? On the Cartesian plane, right? Cartesian plane is just like your x-axis and y-axis, right? Okay. Right. So the point P, right, can be written as X and Y, right? So if our coordinate is written as in coordinate form, it should be X, Y. To write it in vector form, it will be X over, well, X on top, Y underneath, right? So we're going to first write this A in vector form. So watch it. A, go back to blue. So therefore, A can be written as, is it 2, -2, and 3, right? -2 and 3. Cool? Everybody got there? Kill them. There we go. 2 and 3. That's A. Right. So they said this transformation here is applied to this coordinate here to give you a new coordinate A prime, which is A, B. So we need to find A and B. So let's write it down. When you apply a transformation to T, right, you simply take the transformation matrix and multiply it by A. which is the coordinate, to get the new coordinate, right? So I'm going to write down what the transformation matrix is. Transformation matrix is the matrix that's going to change the coordinates, right? So there'll be 2, -1, 2, and 0. So there'll be 2, -1, 2, and 0. That's my transformation matrix. And A would simply be -2 and 3. So you apply a transformation matrix to your coordinate to get a new point, right? Which is A prime. Right? So you all would be the matrix multiplication for me, please. Row by column. There we go. 2 by -2. -4 plus -1 by 3. Everybody good here? Right? 2 by -2. And then 0 by 3 is? So we work in, because I hear more of you all answering, right? So we work in. So we want to find, this is what our A prime would be, right? So -4, a plus and a minus is a what? So let me just put it in a little red minus above here. So this will be -3, right? So -4 minus 3 would give me -4, -7, and -4 plus 0 would be -4, right? So this is A prime in column vector form. So we must write it in coordinate form because it did ask us to find A and the value of A and B. Oh no, well it just want A and B. So we could just put therefore A. A would be which number, guys? -7. It will be the top number, right? And B is what? -4. Proper thing, right? Proper thing. This is a long question, but I wonder if you had the time. Any time now. All right, let me go. Now, what's something here? They said determine a transformation matrix which maps A prime back onto A. So watch it, eh? This is going to be some transformation matrix, I'm going to call it A, B, C, D, right? Is going to map the matrix A prime. What is the matrix A prime? We just found that, right? Well, a matrix A prime is a coordinate A prime that we're going to write in vector form, right? So what is the coordinates of A prime? -7 and, right? Very good. And this will be equal to A. What was A? Dequan. Dejuan. You hear? There we go. What is A? -2 and 3. Everybody with me? They said determine the transformation matrix which maps A prime back onto A. So we actually want to know what is this matrix here. Okay? So it comes like I want to do a reverse of what I did before, right? Which is matrix multiplication here, right? So row by column is equal to this. Row by column is equal to this. Right. So I'm going to run row by column would be equal to 2, right? Then row by column would be equal to 3. Wait. Here, this will align it up wrong, right? Align it up wrong. That's all. Erase this. Erase this because it's simply the inverse of what we just found. So watch it. Align it up wrong. Right. So which transformation maps A prime back onto A? The original work was A. The transformation by A is equal to A prime, right? So if I want to find out what will map A prime back onto A, you actually have to carry T here, and it will be the inverse of T. So A will be equal to T -1 by A prime. Okay? If you want to find out what will map the prime of A back onto A, is the inverse of the original transformation matrix, right? What was the original T? T was equal to what? What T was? Anybody wrote it down? Look at it. 2, negative 1, 2, 0. Right? 2, negative 1, 2, and 0. Right? So we need to find the inverse of t. Right? So I want you all to work that. Find the inverse of t. Right? You all have your process. Find is the same thing we're doing over and over here. It'll be 1 over the determinant of multiplied by adjoint of t. Cool? What is the formula to find the determinant of t if t is a, b, c, d? A, d minus b, c. Everybody good here? What is the movement we're making for the adjoint of t? Everything in all the book, you know? What's the movement we're making for the adjoint of t? Say it again. D come in here, A come in here, then what come in here? And negative C. Right? Everybody good there? And this is when t is equal to A, B, C, D. Right? So watch it. I'm going to write a little A above here, a little B under here, a little C, and a little D as guidance when I'm going to work these, right? Everybody clear? So let's work. Let's work, Jivan. So we go and find the determinant. Therefore, the determinant of t would be equal to, what is A here, guys? What is A? 2 by what is D? You're not seeing it up there? Right? Minus what is B? Wait, I put this wrong, right? Yeah, this is supposed to be B. I come down, I do A, B, C, D. Right? So it's A, B, C, D, right? So, right. What is B? B is negative 1. And what is C? 2. Right? So somebody give me what my determinant is. Anybody worked it? Positive 2. Right? Because 2 by 0 is 0. 0 minus negative 1 by 2 will be negative 2. 0 minus negative 2 will give me positive 2. So this here is my determinant of t. I'm going to put the adjoint right next door here. Right? So the adjoint of t would be, mix it up for me. What going where? Day one. What we mixing up here? Day one, you're not seeing it good? Oh, it's too bright. You find it too bright? Huh? Let me look down the brightness of it because I see a squinch in the eye. Tell me this class. Huh? Yeah, we had a pause for it. Well, that's gig. Okay, so we just rest on. We place the adjoint here, which is the 0 takes the place of the 2, and a negative 1 becomes positive 1, negative 2 becomes negative 2, right? We have it written here. All right, let me send down this. All right. Right. We're trying to find the inverse of t, right? So I'm now going to put back my formula because I want to remember it. What's the inverse of t, guys? The amount of time we write this to the class. 1 over the determinant of t multiplied by adjoint of t. Write it over. So it'll be 1 over what's the determinant of t? 2 multiplied by what's the adjoint of t? 0, 1, negative 2, and 2. Right? So we'll work it out because they wanted the matrix, just a single matrix. So that's why we need to work it out. So there'll be a half multiplied by everybody inside here. A half by 1, a half by negative 2, and a half by 2. So what would be my transformation matrix, which would map A back onto A prime? Sorry, A prime back onto A. It will be t, the inverse of t, which will be 0, because a half by 0 is 0. A half by 1 will be what? a half by -2, -1, and a half by 2, 1. So this is my transformation matrix, which maps, I'm going to write a little statement on it underneath here. Right? So therefore, the transformation matrix that maps A prime back to A is what we just found there, T prime, right? 0, a half, -1, and 1, right? Now, how I'm giving you all homework, right, is it will have like the questions like these. I will need to show you all this next week, but this is some working, right? So we're not attempting this. Anything I put the red by, we're not attempting, right? All these y'all could do. All these y'all could do. I'll send this down, right? Fine, right? Y'all could do this, that one like what we just did. But or you could do most of these, you know. Describe fully. Right. So some of these, you just have to use the notes that we did above to just describe if it is a reflection in the x-axis, like all these things. But I'll give you all a little chance to figure it out. Now we would be doing all of these questions in class next week, right? But I don't want to give you all anything you all will struggle with. Right, like these. You all won't be able to do these. The combined transformations. Right? I will do that. I will do that next week. Combined transformations. You all won't be able to do this too. Anything you all see the red as the red curly bracket by, don't attempt, right? I don't think I want you all attempting this one. This is the last one here, right? And we will do this one next week also. Right. Right, so from here, so complete questions without curly bracket, right? Okay, I can pause all this, but